Welcome to your own channel of Right Funda. Some student has asked this doubt. Let's read the question. This is from kinematics, projectile motion. Question says that velocity of a stone projected 2 seconds before it reaches the maximum height makes an angle 53 degree with the horizontal. Then what is the velocity of the projectile at its highest point? Hope you have understood the question. You can try solving this problem. So is saying that there is a projectile motion. Suppose I take this as the x-axis, horizontal x-axis, and this I take the y-axis. A projectile is projected here with some velocity. We don't know, velocity not given, and it we know all goes no. This moves in a parabolic path. What is at some time here before reaching this 2 seconds before the velocity right now? This angle is equal to 53 degree. This angle with this velocity not given. What is asking that what is the velocity at this point? Question is asking what is the velocity at this point. So all of you can try this one. Very easy questions. You can pause the video and you can see the solution again. So what will happen? Let's discuss this. What is the initial velocity not given to you? What is the initial angle of projection not given to us? What is given to you right now? Before 2 seconds, the velocity was making an angle. It was moving, making 53 degree angle with the horizontal. What is the velocity at the highest point? So if you don't know, suppose the velocity is v at this point, and this is the velocity at the highest point. So this velocity will have two components. One will equal to vx, one will be equal to vy, or I get the v1x, v1y. I given the name. So its velocity equal to at this point is v1. Name I given the v1. That is 2 seconds before this one. This we know that this velocity remain unchanged. What is the v1x is there? Same thing will be here. At the highest point also, this must be equal to v1x only velocity. What about the velocity? But we don't know what is the velocity here. But what is given that this makes an angle 53 degrees. So we know that tan 53, we can write that tan 53 is equal to v1y by v1x. This component by this component is equal to tan of this angle. Okay. So this is one equations we know, and this will be our answer. This one will be our answer. So, but once we know this one, that our only answer. So from this we can obtain the equations like this: v1x is equal to v1y by tan 53. Or we know the value of tan 53, so we can substitute the value, and v1x is equal to tan 53 equal to 4 by 3, so we go 3 by 4 v1y. So this is our answer. So if we once we calculate v1y, that the vertical component velocity at this point, then automatically we'll be getting the velocity of the horizontal velocity can be calculated there. So how to calculate this v1y? Let's see the how to calculate v1y. So if you see, observe the motion from this point to this point you observe, it is the highest point. So highest point means in vertical velocity becomes 0. So whatever velocity, vertical velocity was that becomes 0 by the time it goes from here to here. So if I start my stopwatch here, my stopwatch will read how much? 2 seconds here. So if I apply from here to here in the equation, v is equal to u plus et, v is equal to u plus et in this, in the y direction, then I will get the equation that after 2 seconds velocity become equal to 0. So I write the 0 is equal to v1y was the velocity, or this plus g minus j cap into t. T is equal to 2 seconds. This much j cap velocity was there, and after 2 seconds become equal to 0. So I got from this equation v1y can be calculated 2 into g. So this is equal to g at 10 meter per second, so equal 20 meter per second was my velocity in the y component velocity at that instant when the velocity was making 53 degree angle with the horizontal at that y component velocity. So if I take this value and substitute here, then I get the equation that v1x is equal to 3 by 4 into v1y is equal to how much? 20 meter per second. So I calculate this is equal to get cancelled to 5, and I got the 15 meter per second is the horizontal component velocity at that instant. And we know the horizontal component velocity remain unchanged. So Whatever the velocity was there at this time, horizontal component, that horizontal velocity will be here also. The same thing. And vertical velocity is equal. So net velocity of the particle at this instant is equal to this one. We got the answer. Net velocity at the highest point. If its velocity was making 53-degree angle 2 seconds earlier, then by the time it reaches the highest point, the velocity will come equal to 15 meter per second. So the answer for this question is 15 meter per second is our answer. Now, after solving this one, you solve two more questions based on this. Suppose it was here right now. So from this, it traveled like this and gone like this. So calculate the velocity, how much below it was there. How much below? Suppose I draw a line like this. How much below it was there from the highest point? When it was making 53-degree angle, how much distance below it was there? Suppose this distance I want to calculate as this. How much distance below it was there? You want to calculate this value. And second question you calculate ki after traveling how much horizontal distance, it will be at the same vertical level as the point where it was there 2 seconds earlier, or when velocity was making 53-degree angle with the horizontal, whatever height it was there, at the same height after traveling how much distance in the horizontal direction, how much distance traveling horizontal direction, it will be at the same height there. Pause the video and try solving the problem. Hope you have solved the problem. Let's how to calculate this one. This height to be calculated. How to calculate this height? Because from this point we know this velocity we don't know. At that time the velocity y component velocity got 20 meter per second. So from this 20 meter per second the velocity become equal to 0. So if you apply from here to here, you apply the equations. Either you can apply the formula for maximum height formula, you can apply from this to this. Further this velocity to be required and this angle is required. Or if you apply this velocity horizontal velocity and vertical velocity becomes 0. So if you apply v square equal to u square plus 2as formula you will apply, then you will get the 0 square at the vertical component square is equal to initial vertical velocity square plus 2 into a dot s g minus j cap into h j cap or h dash j cap, whatever name we put h dash. And this will go to 400 is there because 220 square is there. So h dash from this we can calculate the v1y square by 2 into g. So we got this equation 20 square by 2 into 10. If we simplify, this come out to be equal to 20 meter. So it was below that point at a height of 20 meter below the particle was there. Second question is how much distance travel. So here to here traveled 2 second time. So here to here going again same level. It will time of ascent will be equal to time of descent same level. So from here to equal to 4 second time it will take from here to here. And by that time how much horizontal distance covered. Suppose I give the name A here and give the name B here, then the AB distance can be calculated to be equal to AB is equal to horizontal velocity that remain unchanged, uniform velocity traveling, and the time of flight is equal to from that to the equal to 4 second time there. So we multiplied 15 into 4 meter per second to second is equal to 60 meter. So AB distance will be equal to 60 meter distance. So we calculated that if the particle is here where it is making 53-degree angle it is making with the horizontal 2 seconds earlier reaching the maximum height, then its horizontal velocity how much will be there, vertical velocity how much will be there. We calculated 120 and this, and the speed it will be 20 and this 20 square plus 15 square I'll do and square root of this net speed I can find out. I got the how much below to there and how much distance you have to travel. Hope you have understood the problem.